Hello everyone, welcome to lesson 4 of Staying Cool. We are at point 5, heat transfer. So far we did specific heat capacity and we did how heat is a form of energy, and also very important is that heat travels from areas of high temperatures to areas of low temperatures. And heat has several ways of getting around. It can go through solids, liquids and gases, and it can even travel through empty space, vacuum. We feel the heat of the sun. Even though there is empty space, there is vacuum between the earth and the sun, but the heat still travels. And heat travels by 3 methods: conduction, convection and radiation. We're going to divide them into 3. Basically, conduction is the heat transfer in solids. Everything that is solid will transfer heat by conduction. Convection is the heat transfer in liquids and gases, so fluids basically, while radiation is the heat transfer that can pass through everything, even vacuum. The first thing we need to discuss is conduction. And I need you to take a note of this URL, or else on YouTube type Eureka episode 24. So I'd like you to pause this video, find Eureka episode 24 and watch it. After that you can resume with the video and you will understand what I'm trying to say much better. So, taking in consideration the video, I prepared you a PowerPoint presentation so that you can understand me better. Obviously, I'm going to send the PowerPoint presentation by email. So we're going to talk about conduction of heat based on what you've seen from Eureka episode 24. So we said that solids have their molecules tightly packed, they are next to each other, and they are vibrating, jiggling sort of, they are dancing. But they are dancing and never leaving their space. So if we have this atom here that gets heated and it starts to vibrate, it's going to hit the one next to it. And this gets heated and hits the one next to it. The result would be that they all will hit the ones next to them. And so the heat will start flowing from one atom to the other. But we know that there are certain materials that get heated very quickly and certain materials that don't. For example, if we look at the saucepan, you know that when you cook, the saucepan, this becomes hot, but the handle doesn't. Let's go a bit back. So, we're saying that particles of any material are vibrating all the time. They could only stop if frozen to minus 273 degrees Celsius, which is the absolute zero, and we don't freeze things in that temperature. So all atoms of any particular solid are vibrating. When heated, the particles gain kinetic energy, and the side where it is being heated starts vibrating more. These vibrating molecules hit the ones next to them, and the process continues until all the solid becomes hot. Just like a domino effect. If one domino falls, the rest are going to follow. So one is going to hit the other, hit the other, hit the other, hit the other. So when you think about conduction, keep in mind that analogy with the dominoes. Now have a wooden spoon or a metal spoon. If you are going to cook food, would you choose to stir the food with a wooden spoon or with a metal spoon? If you've ever done this, you will notice that the metal spoon, if left in the saucepan or in the pan, will get too hot to handle. You can't even touch it, like the witches in the video. But the wooden spoon would be okay. So what is the difference between them? The difference between conductors and insulators are the free electrons present in conductors. So these do not only have the molecules which one hits the other, but they also have these tiny fast-moving electrons that can help to start moving the particles, the atoms, quicker. If I were in class, I would teach you this. I would show you this. I would get a bag of sweets with me and you would really enjoy it. And I would ask you to pass it on, to pass one sweet on until it reaches the student at the back. And we'll have to do it for every student. So it would take ages for everyone to get a sweet. The second attempt, I would take the bag of sweets and I would start throwing them at you. You will soon all have a sweet. This is what happens in conductors. They are heated quickly because the free electrons carry the energy to all particles very, very quickly. So it is the free electrons that makes the difference between the wooden spoon and the metal conductor. This one would have free electrons, so heat would go fast through it. This one doesn't have free electrons, so if I'm heating here, the atoms have to slowly hit one next to each other, next to each other, next to each other. So even though while cooking it might become a little bit warm, it is not going to be too hot to touch, unlike the metal spoon. Okay, this is before the mistake that I made. I pressed end instead of next. So keeping in mind this, that's why they make saucepans with a handle made of some sort of plastic, heat-resistant plastic, and the metal, the pan itself made of metal, so that this heats quickly for food to be heated quickly, but you can still touch the handle because it is not that hot. Why does a metal chair feel cold when you sit on it while a wooden chair does not? Now, after this lesson, you should be able to answer that. The metal chair being a conductor, when you sit on it, the heat that you have will quickly go to the chair. It will conduct it away. While the chair made of wood is an insulator, and so if you heat it, if you sit on it, so you heat it with your body, it does not take the heat away very, very quickly. And there are many examples of this, like for example, stepping on a carpet and stepping on ceramic floor. One would not feel as cold as the other. Okay, so I'm going to send that by email. And now you have your notes here, which you need to fill in. Basically, you have what conduction is and what is happening. In the pictures, we're seeing that where there is the Bunsen burner here, we have a high temperature. And then as time goes by, the temperature of this thermometer starts to increase, and eventually this will start to increase. And if you keep heating, the temperature of all of these will rise. We have a picture of what's happening in molecules. Those in the flame are moving fast, and they are hitting and bumping into these ones that will soon start moving fast. And then you have the definition of conduction. You can highlight it if you want. And you have the difference between conductors, which can conduct heat quickly, and then the next page, insulators, okay, and examples of insulators, read them through. And then we have what's happening in terms of atoms and particles, okay? So I'd like you to read that really well and to mark it all as important. This is all important, okay? So fill it in and mark it as important. As you can see here, this is a normal solid, no free electrons. It's not a conductor. But here, in this picture, there are the tiny green dots, which are the free electrons, making it good conductor of heat. And then you have a question here, which I filled in for you. So all you need to do is copy it. In the next page, you have 2 experiments. These would have been fun to do in class. I'm sorry that I can't do them with you. Basically, this experiment is done to see which metal is the best conductor of heat. So we would do wax and matchsticks here and in the middle, and even here we'll do them. And we'll heat them all at the same rate, at the same time. The matchsticks would have, the rods will have the same thickness, same length. And we will see the matchsticks falling first for the copper, then the iron, and then the glass, or in glass would have used aluminium. So the ones that will melt the wax first and fall the matchsticks first will be the best conductors of heat. Water and gases are bad conductors of heat. And we can prove this with the test tube experiment. So you could take a test tube, we'll put ice, and then we'll put something stuck here so that the ice will not float up. And we'll continue to fill it in with water. I would hold it with tongs from this side and heat the top part. And we will start seeing the top part boiling while the bottom part remains frozen. Okay? So that means that conduction cannot happen in liquids, because while this part is boiling, this part remains cold. So heat is not traveling by conduction downwards. Whereas if it was a solid, it would become hot at the bottom. That's not the case with liquids. Okay?